Okay, so I'm back with another interesting problem. We have the function f of x equals x to the n times the exponent of x. The goal in this video is to find the nth derivative of this function at x equals to 0. So you can pause the video, go ahead and try it, and then you can come back and watch my solution. Alright, let's get into the question now. So the function here is x to the power n times the exponent of x. As you can see, this is a function of its own and this is another function. So it's a product of two functions. We will therefore use the product rule for derivatives. And so we can find the first derivative very easily. So the first derivative is going to be, let me keep this constant. I keep x to the power n constant, and then I take the derivative of exponent x. Let me just do it the other way around. I'll take the derivative of this. So I like to begin with that for some reason. So the derivative of x to the power n is nx to the power n minus 1. So I keep exponent x constant plus I now keep this constant, I take the derivative of this, so I have x to the power n, the derivative of exponent x is exponent x. Alright, so let's go ahead and find the second derivative. So the second derivative is going to be, let's take the derivative of this guy here, that's n into, so I drop the power, n minus 1 times x to the power n minus 2, okay, I keep exponent x constant, plus, I'll now keep this constant, I take the derivative of this, and of course that's going to remain the same, so if I just keep this constant here, I take the derivative of this, so that's going to be n x to the n minus 1 exponent x, plus, I now take the derivative of this function here. Of course, that's just this whole thing here, so I'll just copy down this. Exponent x. Now, by this time, you should have probably realized that the derivatives are taking a certain trend. And so I can, from these two derivatives, I can already see that the nth derivative of x, the nth derivative of x is actually going to be n into n minus 1 into n minus 2 and many other products here into n minus 1. So you can convince yourself that this is what you're going to get if you take the nth derivative times x to the power n minus n, okay, exponent of x, okay, plus, now of course you can go ahead and do all this other stuff here. I really don't want to do this here, but you can actually take the derivative of all these things here. So what is interesting here is to see that even if I don't write all this, remember we are finding the nth derivative at x equals to 0. If you look at all the other parts, they are going to have x to the power something, x to the power something, but of course here x to the power n minus n is just going to be a 1. So the first term of the nth derivative is independent of x, but all the other terms have x in them. So when I put x as 0, just say the nth derivative, okay, I'll just keep it as x for now. That's n into n minus 1, n minus 2, and so on. This is the same as a 1, okay? So I'll just write that anyway, n into n minus 1, n minus 2 times 1. This is x to the power 0, which tends to 1, and then exponent of x, plus all the other terms that involve x. So the nth derivative of f at 0 is going to be, of course, this by definition is n factorial times the exponent of 0, which is essentially 1. And of course, all the other terms will go to 0 because that will be 0 to power anything which is always 0. So the derivative of this function at x equals to 0 is n factorial. Thanks for watching this video. If you find this helpful, give me a thumbs up, leave for me a comment to tell me what you think. Subscribe to the channel for more content like this, and bye. I'll see you in my next video.